For Ray Roussy, the pursuit of his passion for flying is an extension of his determined spirit. It fuels his inspiration and motivation for taking the future of sonic drilling to new heights. Simply put, he's created one of the fastest drilling systems known. By taking an already existing technology and not only improving it, but reinventing it through the innovative application of new ideas, he's been able to manufacture a product that is in worldwide demand. With benefits including its innate ability to forge through overburdened materials, a long list of environmental benefits, and a growing number of new applications. Ray Roussy is a 2010 recipient of a $10,000 Manning Innovation Award.
The sonic drill has some unique abilities, one of which is to drill very fast. And what that allows us to do is to do geothermal installations at a very competitive rate, thereby helping to introduce geothermal as a way of heating and cooling buildings. This machine is by far the best machine for doing that type of work. The way our machine works, it vibrates the drill pipe up and down, plus rotates. And in addition, we pump water in the center part of it. And that acts like a water hammer, which is also vibrating up and down. And that keeps the face of the drill bit open. So they're able to start drilling, pump water, and go straight down. Once we get down to the full depth of our hole, we're left with a pipe that's sticking in the ground, which is essentially open. Then they can take this loop and just put it into the hole without any obstruction. So the insertion can be done in just a matter of a few minutes. Whereas if you had a conventional machine that had a hole that had to stay open, and sometimes boulders come in and fall over, it's a really difficult process. But with our machine, you have that great advantage that you've got a cased hole. So you can just lower the pipe and that they can start vibrating that out. The grout's already been inserted. So when you pull the pipe out, the loop stays in the ground as well as the grout. And then once they're done, when they're finished, all you have is these two plastic pipes sticking out of the ground. If you can do it with a smaller machine, lower horsepower, get it done faster, those all mean less fuel burn and less emissions. And indeed, that is one of the advantages of the sonic drill. It's a piece of mechanical equipment. It's fairly robust and it's repairable. You can keep them going for the next 100 years. And this particular type of machine is able to provide continuous cores of overburden material, which no other machine can do. In addition, we're able to get through any type of geological formation. A lot of people ask us, well, what happens if you hit rock when you're drilling? And I tell them, well, no problem, we just go right through it. So here's an example of a boulder. It's a granite boulder, and this one was only about 5 or 6 feet down in the ground, and we just drilled through it. And when the guys looked at it, we realized, well, maybe we should dig this one up and bring it back with us. So here it is, and there's a hole right through it. Improvement in technology, for example, the drawing system, that is a big help. In the early days when I started, you literally had to sit at a drafting board and make drawings of every part that you needed. And that was a long process. And now they can do it on the computer and have a much better record and do a much better job. The other item that's really helped us is CNC machines. And we have one lathe over there that was functioning, but in the old days that was all done, well, in the old days when I was younger anyways, that was all done manually. We've worked hard and long and spent a lot of time and money developing this technology. Our peers know about our technology and the advancements we've made, but the general public doesn't. So it's really nice to get some recognition, which hopefully will go more to the mainstream public, and to get some recognition for all the hard work and effort that we put in all these years.